Hello. So today we're going to look on geomorphology, and we're going to cover the drainage basin and also the river types. So let's just get an understanding of how rivers are what called behave. Now, so to start with, we can just have a look at the water cycle where we see that for us to have the rain, we've got warm air that needs what's called to rise. And where is this warm air coming from? It's coming from evaporation and also transpiration. So water lost from the water surfaces is actually like ocean, rivers. Even if you put water in a bucket, the loss of water, they will call it evaporation. Then the loss of water from leaves, tree leaves. So here we are saying from what we call tree leaves is actually transpiration. Now that water, what called evaporate, and it's warm air, it warms up, but as the warm air goes up, it cools down. So it cools, what called condense and forming what? Forming clouds. So this, after formation of clouds, we now have our precipitation. Okay. Now, when it rains, the water again has to flow. So you've got water flowing, and some of it is actually sinks in the, what is it? So here, when we're talking of what we call infiltration, we are talking of sinking of water. So it's sinking into the what? Into the soil, into the ground. So when it sinks into the ground, what happens is that if the water, if it is the ground is saturated, once the ground is saturated, the water will start to flow on what call on the top. So you've got surface runoff. And also, if we've got heavy rains, it doesn't allow. So heavy rains does not allow water to infiltrate. So these are heavy rains, we have got more high surface runoff. Or we can say more or high surface runoff. Okay, that's what we have when we have got heavy rains. But if we've got steady rains, so steady rains, normally farmers, they like steady rains because it allows the water to sink into the ground. So steady rains allows more water to sink. That's what we need to know. So I think you have seen that normally if you've got heavy rain, they are associated with the drought. Why? Because it's not it's not that water is just gonna be, more of it is gonna be just run off. It doesn't actually, the soil does not absorb that. Let's go on let's go on and see what we have today. We need to understand these terms. Okay, we need to be able to define these terms. We need also to understand, to identify each of these terms if you are to give a diagram. Okay, now let's look at the first what called first statement here, first term here. It's saying drainage basin. So what is a drainage basin? This is the area through which a river flows. So this is a collection of, we have got the river. So we are saying it's a collection of the river, and its tributaries. Okay, it's a connection of the river and its tributaries. So all with its tributaries, we are saying that's what we call a drainage basin. Okay. So catchment area is a collection area of rainwater in lakes, river, and reservoir. So here, normally when the catchment area, that's where we see what we call wetlands. Okay, so wetlands, I think you know that what is it? You are supposed to preserve wetlands. You are not supposed to build on wetlands, because we are saying this is our source. This is the collection area of rainwater, where, and also remember wetlands, what happens with wetlands? Let me just make you understand here. It's more like a sponge. So they absorb water during the rainy season. They take in more water. So when they take in more water, they release that water, what is it, during also throughout the year. They release in small amounts. It allows most of the rivers to flow throughout the year. Okay, it allows them to flow, not heavily flow, but just flowing, having what call some water for animals to what call to drink on, and also as to use. Then let's look at the river system. So this is the main stream and its tributaries. That's what we call a river system. A river system, the mainstream and its tributaries. And what we can just say here, when not looking at the drainage basin, we can also relate to the river system, because what we are saying is that we are saying in a drainage basin, we have a collection of the river and its all tributaries, where it's coming from, and what we call until it empties the water into the ocean or a dam. Let's look at the tributary. So tributary, so what I can just maybe draw here, let me just draw something here so that you can understand something here. So we have got something like this. So let's just call this the mainstream. Okay, let's just call this the mainstream, and we are saying we have got the tributaries. These are what you call tributaries. Then what you call we have got some going there. That's what you call what is it? So we've got tributaries here, and with the mainstream. So the mainstream. Then we have got the tributary. Then we have got that where these connect, where they connect, what do we call that? We call that the junction of two rivers. So we call it the confluence. Okay, then we have got the watershed. But now I'm going to show you the watershed on the next slide. Don't stress. So we've got the confluence junction of two rivers, the watershed high-lying area that separates drainage basins. Then we have the interflow, which is a high-lying area that separates tributaries. Okay, so we can have an interflow here. So we can have an interflow here. So it's high-lying area that is separating what we call that is separating what is it? Two tributaries. Okay, then we can also have it here. I'm going to show you in the next diagram where we have got something that are easily visible. Then we have the source. The source here is the place where the river begins. So we are saying this part here, we call it the source. Okay, so where the river starts, we call it what we call the source, and the river mouth. So here is what we call the mouth. Okay, the way it ends. So it's the part of the river where the river flows into another river, a lake, or a reservoir, what called a sea or an ocean. So here we are saying this tributary here, its mouth is here. You understand? So for this tributary here, we are saying the mouth here, and also the mainstream, its mouth. This one here can be an ocean, it can be a dam, it can be a, what is it? It can be a lake, okay, where it's emptying its water. Then you have the groundwater, water underneath the earth's surface, and we've got what we call through flow, is a literal flow of water in the soil zone. Then you have the water table, upper level of groundwater. You also understand it when you go further here. Infiltration, when water soaks or filters into the soil. That's what we call infiltration. So sinking of water. So we're just saying we're talking of what we call sinking of water. Okay. Now, let's look at the more diagrams that are what we call more visible. Here, what we can see is that we have got a river here with the mainstream. So this one here is our mainstream. Mainstream. So mainstream, and we've got its tributaries here, and we've got to see that it's raining here, and it goes on. And what do we call this one here? We call this what is it? The source. So let's just have something here. Sorry, man, what we call the mouth. So here is the mouth of the river, and we have got its source, what we call up here. Okay, that's where we have the source, and we have the what we call the mouth, where it's emptying into the what we call into the dam. Okay. Now, let's look at this, what we call this diagram that is what we call, I can say more clear. So what we have here is what we call the watershed. So this is the watershed. So here we can just say this part here, this whole part here, which we call drainage divide. So we call it the watershed. So this can be a mountain. So you can see that these rivers, they actually connect the separate mainstream and they flow what called to different what called destinations. So what we see here, we've got drainage basin 1 and we've got drainage basin 2. So drainage basin, we are saying this is a collection of all these tributaries that you see here in this mainstream here. So we are saying that's what we call a drainage what we call a basin. And once we have these tributaries, you can see that this is a tributary, this is a tributary, and what we see also, these tributaries are separated and what we call this high-lying area here. So we have this high-lying area here that we see is what we call the interflave. This is what we call the inter, or we can call it what we call a spur. So that's what we call the highland area. So it's separating tributaries. But what we see here, highland area separating two drainage basin, we call it what we call the watershed. So let's just label them. So we've got the tributary here. Tributaries. Then we have got what we also have of the watershed, we have the interflave there. So this is also the interflave. This is also the interflave, what we see here. So I'm just going to put what we call these arrows here, so that it shows you what the interflave, where the interflave is. And here we've got the interflave, and we also have what we call the interflave. Interflave here is separating tributaries. So they are tributaries in the same what called drainage basin that are being separated here, but they are flowing in the same direction. But what happens, there is just high-lying area there. Okay, then what else do we need to know here? We have got this part here, we call it the what? The river mouth. So river mouth. And what we see here, we are saying that's where the source is. And we can say all this part here, that's what we call the, what is it? What we call the catchment area. This is the catchment area. That's what we have there. So we have got the catchment area there. I'm just gonna put everything here, guys. What we call catchment area. That's what we get there. Okay, so I hope you guys now understand, even a better understanding of how the river looks like and all these terms. If we are to meet them in the exam, and if you are to have this diagram in the exam, you will have a better understanding of what is going on here. What is going on? Let's go on and see what we have in the next slide. What we see here, that factors influencing infiltration of water. So amount of water that what called sinks into the soil is actually, or sinks onto the ground, is affected by a lot of what called things. So we can start with amount of water already in the ground. So if the water is already saturated, so if we have already saturated the ground, it means that this is not going to allow more water what called to infiltrate again. So we are saying if the soil or the ground is saturated, so saturated ground. Now, when we're saying saturated ground, it's full of water. So it's already full of water, and we are saying it doesn't allow more water to actually to go into the ground. So what happens that saturated water will not have what called will not infiltrate or allow more water to sink. So what happens now, if it doesn't allow more water to sink, what's going to happen here is we've got high runoff here. We've got high surface runoff, because we are saying here the water is already full into the ground, so it doesn't allow water what into the ground. So we are saying if you've got less water, so saturated the ground, it means that this is full of water already. So it's full of water, there's more water in the ground. More water in the ground. So if the soil is not saturated, yes, it's the opposite. We are saying it will allow more water to infiltrate. Okay, so let's just have an evaporation rate. If we have got high evaporation rate, it means that more water is being being lost into the air. It's being lost into the air. So high evaporation rate will not allow more water also to infiltrate. So we are saying this is the water loss. So this is what called water loss into the atmosphere. So if we got high evaporation rate, this will also see that we know much water is going to be absorbed into the ground. Then let's look at the slope. So gradient of what call of the slope. So we are saying steep slopes. So steep slope. So if we have got, let's just save steep slope and a gentle slope. So here, if it is steep slope, what we see on a steep slope, decrease, or we can say allows, does not allow more water to infiltrate. So what we are saying here, if the ground is steep, if the ground slope is steep, this allows more runoff. So it doesn't allow more water to infiltrate if it's a steep slope. But what we see in a gentle slope, here we've got high in a gentle slope. So gentle slope. So gentle slope here, what we see is that we have got high infiltration, because water can actually stay on the surface. So here, but in the case of a steep slope, it doesn't actually stays on the surface. It actually what call have to flow what call on the surface. So here, what we see, gentle slope allows what call hold more water, and in that case here, when more water is just hold here, it will actually be able to infiltrate. So we have got infiltration of water into the ground when you have a gentle slope. But in a steep slope, the water is just what call flowing what call on the surface. So we've got high surface runoff here. That's what we see. But here we've got less surface runoff here. So we've got less surface runoff, less surface runoff. So that's what we see there. So that's what we see on the gentle slope. On the steep slope, we see that we have got high what you call a runoff. So we have got high runoff. That's what we see there. Okay, let's look at the nature and amount of precipitation. Nature and amount of precipitation. We are saying here, if we've got high rainfall, nature amount of precipitation, remember I indicated on the first slide. So I will refer you to the first slide here. I will refer you to the water table. Refer to water. Is water cycle, the first the first slide there, where we said when we have got high rainfall here, heavy rainfalls does not allow what you call much water to infiltrate, because this is the heavy rainfall doesn't allow the ground to actually infiltrate the water. That's why you see after heavy rainfall, you see more water on the ground flowing. But if we have got then after that, it just dries out. But if we've got steady rainfall that just have showers and everything, it allows your ground to actually absorb enough water. It allows the ground to absorb the water. So if we've got heavy rain, does not support much infiltration. Then if we've got steady rains, they actually support infiltration. Okay, now let's look at the density and type of plant cover. So if you've got if you've got densely what you call with more trees, grass and everything, this allows what you call so high density. So I've got more, let me just say density, we're saying more vegetation. Vegetation, we are referring to the trees and what? And grass. So if we've got more of that, allows more infiltration. So if we've got what call highly dense what call high density of what call trees and grass, we are saying it allows more infiltration. But if we have got what call area with a space of what call we have got trees that are far away from each other, we have got what is it? So space vegetation. So it's a what call so we've got space, what call vegetation. This what call does not allow much infiltration, because when you have space with vegetation, we have got high evaporation. We have also what call does not what call because we have got here we didn't have much roots to actually to absorb the water. But when you have got more vegetation, we are saying when talking of more vegetation here, we're just talking of dense. We say it's what called densely or dense vegetation. Okay, dense vegetation, meaning to say we have the trees are close to each other. So we have what closely packed what called trees here, trees and grass that are closely packed. We see that we talk of we refer to as dense vegetation, or we just say more vegetation. But in a space here, the vegetation, it have got more spaces what call on it. So what we have, we've got trees that are what call much divided, and there is much space, open space. So we've got more open space here. So more open space. So in this case here, in space vegetation, there is what called less infiltration. So less infiltration. Okay, that's what we see, because we don't have much trees here to support to actually to absorb the water. That's what we see. Then let's look at porosity. Porosity, this is ability of what we call of rocks. We can refer them to rocks. So ability of rocks to hold water. To hold water. Are we together? So if what you call if the rocks can absorb water, we call them aquifers. So we call them the aquifers. So that's what we have there. So this is the aquifer there. So we are saying, what is it? The aquifer absorb water. So this is the rock. So it's actually the rock that absorb water. So what we call aquifers absorb water into them. So that's what we call we're referring to as porosity. So if we've got rocks that are porous rocks, it means that allows more infiltration. Are we together? It allows what we call more infiltration. But if we've got what we call non-porous rock, which we refer to them the aquiclude, so those ones they can't absorb water. So in that case, they don't support infiltration. So if we're saying we are talking of aquifers, so aquifers increases infiltration because they absorb what called water. Then let's look at the permeability. Permeability, this is the what called ability. It's allowing. So we're talking of soil here, permeability of soil. We're saying when the soil allows or a water to pass through it. So you've got some soil that doesn't allow what called much water to pass through them. We're saying they are less permeable. And those soils that are what called, like, for example, we can say sand. So sand, you've got more space between it. So sand soil are highly permeable. So high permeable. They are highly permeable because they've got more space between them and they can allow more water to pass through them. So in that case here, we are saying in sand soil, we have got high infiltration rate. Then here, when we're talking of a clay soil, you've got particles that are closely pegged to each other and does not allow much water to pass through them. But what happens now, the difference between these two is that clay soil is able to hold the water for a long time, but here the sand soil just what call does not it doesn't allow what call much water to stay in them. It just allows the water to pass through, but does not what call keep the water. So when we have this taste, clay soil is good because it keeps the moisture, or we can say it keeps what call the water that it absorbs. So it keep what call this one keeps water for some time, a long time, when we're talking of what we call clay soil. Okay, now let's look into the next slide here. River types. So you've got what we call permanent rivers that flows throughout the year. Then you've got the periodic rivers that flows every year only in a rainy season. So periodic rivers, they flow every year only in rain season. That's what we see. Then we've got episodic rivers. These rivers only flow for a short period of time after heavy rainfall. So we have got a guide here, heavy rainfall. So once we have heavy rainfall, we have what called the episodic rivers, what called flowing. Then we look at exotic rivers. Exotic rivers, this is a permanent river. Remember, it's a permanent river that originates in a rain or wet area, but later flows through a desert. So this one here does not carry the characteristics of what is it of area around it, or the environment where it's passing. So that's why we see that it's passing through the desert and it's flowing throughout the year. But we are saying in the desert there is no rain much. There isn't much rain there in the desert, but the water is able to flow through the desert. Why? Because where it originates is actually in the rain, what you call, or wet area. Okay, that's what we see. So we've got so let's say just say exotic river. Exotic river. So we are saying with the exotic river, we'll also talk about it just now. We'll indicate to you what this means. I'm going to explain here. We've got water table here. Water table able to what you call intersect with the riverbed. So the water table can, so we've got here, this blue line is during what you call the wet season. This one here is the dry season. So what we have here, this is the water table. So we're saying the water table intersects with the riverbed. So this is what a riverbed intersects with the riverbed throughout the year. So we are saying it's a permanent river. The what called permanent river. So exotic river is a permanent river that is just passing a what called over a desert. That's what we see there. Okay, so you must expect what called the properties of the permanent river in this case. So when we're talking of exotic rivers, we must understand that it's just permanent river that is flowing. So where it's starting here, let's just see here. Let's say it's flowing like this. So we have got heavy, or we can say wet area or high rainfall here. High rainfall, or we can refer to this maybe, let's say, mostly on the equator. So it's passing maybe from the equator where there's high rainfall, it's raining every day, and we've got much rainfall passing here. Then here we have got the desert. And on the desert here, there isn't much, it's dry area. So on this dry area here, we are saying the water still, the river flows. The river flows throughout the year. In that case, it's passing here. So it's starting from the high rainfall area, area and into a desert, then continues like that. That's what we call a exotic, what we call river. Let's look at different other types of rivers. Permanent rivers. So you can see what I have indicated here. This is our water table in the rain season, then the water table in the dry season. So here the blue line is indicating the water table in the what called wet. So this is one, it's representing, these lines are representing the water table. I'm just gonna do this. So this is the water table. So it's the upper level of the water, And what we have here is our riverbed, the surface of the river. So we are saying here, the water table is always above what it intersects what called with the riverbed throughout the year. So here, the what is it? Let's just indicate there. So the water table intersects with riverbed throughout the year. That's what we see there. So here we are saying it's where is it found? In high rainfall area. High rainfall area. So where is always what called raining or wet areas. So that's where we see what called permanent rivers or perennial rivers. Perennial meaning they are flowing throughout the year. So the river flows what called throughout the year. In other words, river flows throughout the year. That's what we see there. River flows throughout the year. Then let's look at the periodic rivers here. Periodic rivers, they only what you call flow during rain season. So they flow during rain season. So water table intersects with riverbed during rain season. So only in rain season, that's when we see what you call the riverbed intersecting or with the water table above what you call or on the riverbed, because we have put much water in the ground because of what you call high rainfall in the rain season. But once we get to the dry season, we see that the water table actually goes below that, and you can see what we have here. Some rivers even dries out during the dry season, and later on what called flow when rain comes. Okay, now let's look at the episodic rivers. So here only we have got these ones flows only. So river flows after heavy rain. So they only flow after heavy rain. So once we have got heavy rain, they can be able to flow. So it's not, they don't flow every year. They do not flow every year. And what we see that, again, the water table does not intersect. Water table does not intersect with does not intersect with the riverbed. Okay, so these are the types of river that you need to see. So you must see here, if you can see what we have got what called soil only here, and we don't have any water around it. Then we can see these ones here trying to flow also, but what we see is we don't have much of water on the riverbed. But here, what we have here, we are saying the river is always full and is always flowing, and that's what we see. Okay, let's move on to the next slide here, where we have a question here to attempt. Refer to Fig 6.1 and under the question that follow. Photograph A shows an episodic river. So we're told that this one shows an episodic river in the northwest part of South Africa. And we've got photograph B shows a permanent river in the same area. So we've got a permanent river and a dry river. So if orange river here, then the dry river here, where there isn't much flowing there going on, or there is no flow at all. Now, what is an episodic river? Episodic river, a river that flows only after heavy rainfall. So this is the river that flows only after heavy rainfall. That's what we have there. So it's number 6.11. So it's A, okay, a river that flows only after heavy rainfall. You can see that it's 1 point, but you are going to be given 2 marks for that. Now, give evidence from the question 6.1 photograph to support your answer. Okay, let's support the answer. What are we seeing there on the riverbed? What are we seeing on the riverbed there? So what do we see there on the river? We see boulders, we see more visible. So we've got rocks here. So we've got visible rocks and boulders on the riverbed. Okay, then we also have dry. The other reason also, you can see that there's dry riverbed. That shows that this is an episodic river. Okay, so if the dry riverbed here, what you can see some boulders here, some rocks around here, and you can also see that this ground is what called dry. You can see that it's dry, and that's the reason that you're given, because what are you doing here? You are referring on the photograph. You are referring from the photograph. We don't give general answers here. We are just referring to what we see on the diagram. That's what you must actually indicate there. State 2 physical factors that will influence the discharge or stream flow of this river. Okay, so let's look at what actually affect the stream flow of the river. So we have so many factors there, which include so we've got 1, frequency of rainfall. So if we've got much frequency, if we've got more rainfall, like we have got a sequence more rainfall, raining over some time, and we're saying it's a frequency. If we've got high frequency of rainfall, we also see that our river will be able to flow. Then again, amount of rainfall, when it rains, how much rainfall actually falls on the ground. So amount of rainfall here. So if we've got more rainfall, it also allows much stream flow. Then let's also talk of rate of evaporation. Remember, we once talk about it, on the infiltration, we were saying if we've got high rate of evaporation, it means that there isn't much water also going on the ground. So the same applies here. If we've got high rate of evaporation, it means that there isn't much water to flow on the riverbed. Okay, let's also see other things that we can also think of. So we can include the river gradient. So we remember what we indicated, the stream flow. If we have got influence the discharge of this river, it means that if we've got steep gradient of steep rivers, it means that more water is just gonna flow quickly, does not hold the water. So if we have got more gentle rivers, they also allows water to stay. And if it rains heavily, it means that we've got more water around in the river. So we have got much flow there. Then we can also talk of soil types. Okay, so soil types also influence what call the what is it the stream flow. If we have got much sand, high infiltration, if it just rains here, it means that all the water is just gonna what call sink in, and we don't have much what call water flowing, unless if we've got the heavy rainfall that what call that we have. In that case, we can have some water flowing on the surface. Okay, what other things can you also think of? Soil water content. So if the ground is saturated, it means that if once it rains, we have got more water flowing. We have much stream flow there. So amount of water also in the ground already is also determines whether we are going to have much stream flow or not. Then we have got infiltration rate. Infiltration rate. Then we also have the vegetation density. Vegetation density. Then what else do we have seeing that affect stream flow? I think you can also add yours, but any of these two will give you your 4 marks. Okay, so you must be able to understand when we talk of factors that affect stream flow, is also the same as factors that affect your infiltration, so into the ground. So those are the factors that you must think of and and indicate them. So what do you call a permanent river that flows through a dry season? So remember, we just talked about it just now. So it's an exotic river. Then explain why the river in question 6.1 flows throughout the year. So we can have 6.12 B. Why does it flows throughout the year? So if we refer back from what we have learned now, that permanent rivers, exotic rivers are what we call permanent rivers. So why are we saying this is flowing throughout the year? Because it's gaining water from high rainfall area. So it gets water from high rainfall area, or you can just say wet areas. Wet areas. Okay. Then we can also think of we can also think of where your stream flow exceeds infiltration. Okay, then we can also talk of high groundwater, more groundwater. So if you've got more groundwater there, it means that the water is able to because more groundwater, it means that whatever amount of water that we're going to gain there is gonna just flow on the surface, because we already have much water on the ground. Then what else can we talk of? I think here we can end 2 of them. You can indicate them, then you get your marks. Then let's look at number C. 6.1 to C, we see that it's asking us 32 advantages of this river for farmers in the north western part of South Africa. So they are able to do irrigate. So they are able to irrigation. So we've got irrigation there. We've got regular water supply. So they are having more water supply here, and also lastly, we can think of what called stock farming, or we can just say livestock farming. So stock, we're talking of livestock farming. Yeah, they can have what called e.g. kettles. They can have kettles, goats, sheep. We have because there is much water there to actually to use for them to drink. So that's what we to call stock farming. Okay. So I think for today, guys, I'm going to send you upload also work that you need to do. And I think for our first class, we are done now. Thank you so much. Until next time, all the best.